Hi, welcome everybody. My name is Colin Bancroft from the Manufacturing Technology Centre. We're just waiting for more people to join the webinar, and then we'll be looking to start at 2 o'clock promptly. So thank you. I hope you're making the most of the sunshine today. If you are based in the UK or wherever you are in the world, I hope it's nice and sunny for you. And like I say, we'll hope to start shortly. Hi, I see people are starting to use the chat function, so welcome. Hope you are going to look forward to the fourth webinar in the additive manufacturing series. We're just going to wait till 2 o'clock, wait for more people to join the webinar today, and then hopefully you'll enjoy the subject matter of developing a business case for additive manufacturing once we start shortly. So we've just turned 2 o'clock. People will still be admitted as they come onto the webinar. But I'd like to just welcome you all to the fourth webinar in the additive manufacturing series. And this one is based on the subject area of developing a business case for additive manufacturing adoption. My name's Colin Bancroft. I'm Key Accounts Manager here at the Manufacturing Technology Centre. But what I'd like to do is just remind you that this session is going to be recorded and can therefore be viewed at a later date, and the links to the recordings will be emailed out to you in the coming days. We'd also like to inform you that all mics and videos have been disabled, but for any reason you do find your video or mic is on, could I please just ask you to politely turn this off, as we want to ensure that we provide the best experience for you all. We'll also be taking questions throughout the webinar, so please feel free to use the chat function at the bottom of the screen. If you do move your cursor, you should see this appear in the ribbon at the bottom. I'll be monitoring these questions throughout and then can pass on to the presenter at the appropriate time. And if for any reason we don't get the opportunity to answer all questions, we'll be responding to those unanswered questions via email, and that'll again be communicated out in the coming days. My colleague will also be supplying links into the chat function for my contact details and that of Paul Duffy, the presenter of today's webinar, along with links to our training website and where you can get access to our additive manufacturing training courses, along with the training needs analysis, which we'll be discussing later throughout. What I'd like to do is just give you a brief introduction if you're not aware of the Manufacturing Technology Centre. So if we just flip to the next slide, please, Paul.
There we go.
So we are one of 7 of the high value manufacturing catapult centres based across the United Kingdom. We're based actually in Coventry, in the centre of the UK, where we are the home to the National Centre for Additive Manufacturing, where we've got over 100 dedicated engineers to this specific subject area. We're also partners of the European Space Agency, where we are one of their partnered benchmarking centres, and we're also part of the ASTM Centre of Excellence, helping develop the standards for additive manufacturing. What I'd like to do now is just introduce Paul Duffy, my colleague, who's a lead advisor for the Manufacturing Technology Centre within the transformation team, who will now deliver the webinar on developing a business case for additive manufacturing adoption. Thank you very much, Paul.
Hi all, so thanks for joining us this afternoon. As Colin said, my name's Paul Duffy. I'm a lead advisor in the transformation team at the MTC. The transformation team are primarily focused on getting businesses operationally ready for insertion of new technologies, such as additive. So really looking at your whole sort of business strategy, operational excellence, and business cases for inserting new technologies and identifying the most appropriate technologies for your business. So objectives for today. So we're going to talk about the role of the business case in the next steps towards your additive manufacturing implementation. And we're going to think about what opportunities there are for adopting additive manufacturing, and hopefully sort of stimulate your juices, get your juices flowing a little bit on the art of the possible, potential barriers and risks, and some mitigations to those barriers through alternative routes to adoption of the technology within your business. We're going to briefly look at costing additive parts and facilities, and how to build that into developing your complete business case, and getting stakeholder buy-in for that business case, and selecting the most appropriate scenario and strategy for you going forwards. And then talk a little bit about next steps. What do you do once you've got your business case, and support that's available both from us at the MTC and the Advanced Manufacturing Training Centre, and elsewhere outside of the business as well. So first of all, I'm going to talk and give an overview of some of the opportunities that you may have in your business for adopting additive manufacturing. I like to think about all of the opportunities in terms of this, this simple Venn diagram that we've got here. I think traditionally, perhaps when you're buying new technology or new capacity into your business, one of the foremost considerations is the cost of producing parts. So additive manufacturing can give you cost savings in your manufacturing process. This might be an opportunity to develop a business case. So examples might include simplification of your production processes. So you may be able to rationalize the numbers of processes that you've got, increased capacity and leaner manufacturing. So you may be able to free up some existing capacity by using additive for some of the more variable parts that you're making, for example, bringing capacity into the business. Less wastage of material. So unlike traditional methods, which generally take material away, we call them subtractive methodologies, and you get a lot of swarf and a lot of waste metal or waste material. Additive works the other way around, obviously adding material onto the product. So actually material wastage is very low, typically with additive processes. Additive is very flexible in terms of the volume of products that you're making as well. And you may find that you've got a case for additive being able to massively reduce your lead time of either getting product out to market or product made to demand, and thus you can look at reducing your inventory and improving the cash flow of your business using this technology. A lot of businesses adopt additive for its performance and product life, or product performance and life cycle benefits. So again, you may be able to consolidate parts. So instead of having complex assemblies, you may be able to consolidate them into a smaller number of parts. Increased complexity for performance. So you in industries such as medical devices, aerospace, automotive, you may be able to get an enhanced performance or novel features in your product that you couldn't make using conventional methods. Lightweighting of parts, so it's quite easy using additive to create internal structures to give yourself strength in the products without using so much material and making much lighter parts. So obviously in fields such as aerospace and motorsport, for example, there's a big business case often for using those features as an advantage. And optimized materials, so there's a different range of materials potentially available to you if you're using additive. And some businesses really fundamentally base a new operating model or a new business model around the adoption of additive. So you can actually do things like localized or decentralized manufacturing production. You can customize all your products, so mass customization. If you think about things like healthcare, it's a really valuable asset to have. Maybe you want your replacement hip making specifically for your hip socket size, so there's a strategic advantage there. Meeting just-in-time needs as well, so you can actually get your hip next week potentially, because there's not a lead time in producing tooling and things like that. And of course, cost-effective spare parts. So if you think about things again like the aerospace industry that's got inventory around the world to account for aircraft on ground and areas like that, then actually being able to make specific parts without any changeovers rapidly and locally is hugely strategically valuable to those. What we've typically found on this Venn diagram when we ask industries about it, and by all means comment on this in the box, is most businesses start by thinking about a strategy for product performance and lifecycle benefits, or perhaps new business opportunities. And it's typically because it's still a fairly emerging technology. So actually additive is typically more expensive. An additive part's typically more expensive than a conventionally made, say, injection molded plastic or machined or formed piece of metal. However, what we have observed as we've followed businesses through their adoption and their longer term strategies and the general trend over the last few years is that the cost of materials and processing in additive is gradually reducing as it's becoming less of a disruptive technology and more of an embedded and accepted technology. So metal powders, for example, are becoming cheaper year on year. So actually, if you were to plot yourself in the Venn diagram, you quite often find yourself over the number of years that you may want to map your business case, moving out from the top and the bottom left and further towards the bottom right as well. So you're getting more multiple advantages as time goes on. Okay. So a little bit more detail on some of those opportunities. I like to think about them in terms of both the manufacturing business and the customer themselves. So from a customer perspective, there's more geometric design freedom, so you've got more opportunities to make novel products. And I'm sure many of you seen some of the really exciting sorts of parts that you can get from additive that you just can't imagine how you'd possibly make it any other way. More material design freedom as well, and of course customization and personalization. And that really applies from very high-tech industries to consumer goods as well. So jewelry making might be an example there. There are limitations, of course. Typically, the size of the parts is limited, especially if we're talking about high-end or metal manufacturing. So it depends on the manufacturing bed of the machine. Typically, maxing out at about 350 mil cubed, maybe a little bit bigger with some of the new machines. And cost. From a manufacturing business point of view, again, you may be able to consolidate parts or remanufacture obsolete parts that you haven't been able to do. And you've definitely got the opportunity to have this faster iteration from design through to part. But there is no denying that as you get into the higher technologies, particularly around ceramics or metals, but even polymers, you look at the machines are still high cost and the materials are still high cost as well. So typically you're not, I think this is why we need to talk about having a sort of fairly sophisticated business case, because we are talking about significant investments still in this area. Okay. The other thing to consider in a manufacturing business as well is that when you're developing a business case, I think it's quite easy to get sometimes from press and hype that you can effectively buy a 3D printer, design your part, and then you can make whatever you want the next day. And it's really not as straightforward as that. So you need to consider the whole value stream with material handling, powder management, potentially the actual additive manufacturing process itself. Post-processing for metals, for example, often includes heat treatment, more machining, and potentially hot isostatic pressing and things like that to get highly dense parts as well. And you may also need to consider your infrastructure requirements. So you may need some environmental controls, extraction controls, and things like that that you don't necessarily have in your facility at the moment. So a little bit more depth about some of the advantages and opportunities that we've talked about. So just to bring it to life a bit, enhanced design freedom. Really, here on the left, we've got a diagram of a hydraulic manifold that's traditionally machined from a solid block of metal. Straight lines, obviously, for flows in the manifold itself. And through a couple of design iterations that you can see, there's real opportunity to lightweight that part. Perhaps a little bit of a scary picture of a manifold on the right hand side for some people to accept, because it doesn't look like a proper one, if you like, but actually you've got all of the functionality in there, and you can design in strength points where they're needed. You could potentially go a step further than that as well and start looking at more organic flows through the manifold, depending on the design constraints that you've got. So you can really add greater value to the product, and it's more likely that you're going to get that out of it to start with than to reduce cost. So generally your business case will be around added value, and potentially looking at, you get more added value if you're doing product redesign. So it would be very difficult to justify a business case if it's based on making legacy parts with the same design to reduce cost. That's generally not going to give you the payback that you need, but you need to think outside the box a little bit in terms of next generation of products. Okay. So personalization and customization we touched on. So mass customization, I mean, the market is really increasingly demanding more personalized products. You can see the obvious benefits in the illustrations that we've got below. So obviously in the healthcare sector, this is a really sort of leading edge technology for getting your personalized products as you'd want them. Hopefully nobody in the group would need the one on the right hand side, but perhaps the one on the left hand side might be a bit more common. Okay. Distributed manufacturing is another big strategic objective and opportunity to build a business case for additive. So effectively you can have your engineering on one half of the planet, and you can print remotely anywhere else on the planet, or as for the example that we're showing here, off planet. So this is a 3D ratchet that was needed to make some repairs on the International Space Station. The designs were beamed up and printed off locally. So you can imagine some of the uses of this in terms of spares, tooling, and localized production in remote locations that don't necessarily have the engineering expertise that you might want to transfer. And you can do all of that instantly as well, because as soon as you've got the digital design, you can effectively send that and make it locally. So it's potentially a strategic example that might be worth thinking about in your business case and quantifying as well. So tooling elimination, rapid changeover might be a really good opportunity for you to think about reducing cost and lead time in your manufacturing cycle. So when you're doing your business case, it's always worth looking at a methodology such as value stream mapping, conventional methods for making this part, because you may actually find that it's not just the obvious costs that are in there, but the costs of inventory and the added cost and risks of extended lead times of batches of inventory between different processes. It's often quite it's possible to eliminate that by using additive manufacturing, because you don't have so many processes, and you certainly don't have any changeovers. There's no risk of tooling failure, and new tooling is often a bottleneck. So if you're maybe casting or forming parts, then tooling can actually take quite a long time to come. And if you're thinking about things like prototyping or rapidly changing the design, then it can be a bottleneck, and it can mean that the competitors can get to the market before you. We've seen examples of businesses actually using additive just to demonstrate that they can produce a design and get it to the customer, within days or hours, rather than traditionally perhaps weeks or months where they've been waiting for tooling. So real competitive advantage that you really need to think about quantifying in your business case as well. This is an interesting one. So reduced assembly operations or part consolidation. So we found that typically you can reasonably easily consolidate up to about 25 parts into one print. The example that we've got on the right hand side here is an engine air brake that was produced by the drama project here at the MTC. It's actually a moving part, so the flaps that you can see in the device are actually motorized now at the MTC using the gears underneath, and that's all printed as one. So it's perhaps a bit of an extreme example, but if you think that you can eliminate the need for a lot of your assembly operations, you can eliminate the need for a lot of your fixtures and fittings, and therefore you're eliminating a lot of the potential quality failures, maybe supply chain shortages that you get on those parts, and you're generally simplifying the manufacturing process by consolidating everything into one assembly and effectively into one process. So there's cost reduction to be had in that, and of course reduced lead time. So although you can't typically produce parts at volume using additive manufacturing as fast as you would perhaps injection molding, even machining, but certainly casting and forging and processes like that, actually the lead time to changeover is a lot smaller. So it can, depending on the type of product that you're producing, massively reduce your lead time. And actually we're finding increasingly now that you can build more and more products on a single bed, on a single print. So although the process itself may take a number of hours, potentially you can build quite a significant batch of parts if they're not too big. And of course the lead time to actually making that part from design is as little as none. So we're sending the digital data over to the machine, and there's no need to wait for tooling, no need to wait for machines to be changed over. So it's the ultimate sort of SMED activity, or rapid changeover activity, if you like. We need to think about, in your business case, this may seem a little bit intangible to some, but try and quantify that readiness for future market opportunity. So an example here might be a parallel would be the composites industry, maybe a decade or 15 years ago, looking at aerospace. So over the last decade, a lot of the aerospace primes and tier one suppliers have actually consolidated the composites market and the composites manufacturing businesses by buying them out effectively. And they've what these businesses have done is seen the future opportunity in that technology, and now it's embedded into aerospace. And additives perhaps at the same sort of stage. So a lot of businesses out there are adopting additive now, and part of their business case is actually to demonstrate capability, to learn lessons now, to build the engineering expertise, to prove that they're ready when the end customers do come along and say, actually, we are now ready. Our next generation of engines or our next generation of Formula One cars or whatever it may be have now got a demand for more additive parts. Are you ready to go? You've already had that early adoption. You've already learnt your lessons. And you've demonstrated that you're number one in that marketplace. So although it may not have the payback immediately, as you may expect on a traditional business case, there's quite a lot of value here really in proving to those OEMs and primes that you're the number one supplier and you've got that knowledge in-house. So I want to talk a little bit about potential barriers and routes to adoption. So ways that you might overcome those barriers. So the way that we did this, we asked a number of businesses what were their perception of barriers to entry into additive, what was holding them back in their business case. One of the primary factors in that was really lack of technical knowledge and skills and capability, and that's not necessarily just internally in their business, but generally in the marketplace. It's a technology that, you know, although it in essence has been around 30 years, it's really only started to take off from going beyond the early adoption stage in the last few years. So there isn't a great wealth of engineers out there that have done a lot of work with additive. So really overcoming the skills and capability, obviously coming to places like the MTC and the training centre, the Advanced Manufacturing Training Centre, are valuable. But we also find that the guys that make the kit, you know, the additive machine manufacturers, are really supportive in developing your business and knowledge. But it's something that does take time. And even at the MTC, we've had new machines, and to commission them sometimes takes a while as we learn the lessons of the nuances of how the different technologies work. So getting in early, again, is really important to overcome that as a barrier. And get past that fear, really. Process capability and repeatability. So there's no denying that for highly accurate parts and dimensional repeatability, additive it can sometimes find it hard to compete with machining, for example, in metal. But it is getting more and more repeatable each year, and it's important to remember that you don't usually use additive on its own. So generally, if you're after a good repeatable surface finish or dimensional tolerance, then you're going to be still having some post-process machining and heat treatment and things like that anyway. Design authority, so really acceptance into the market and acceptance with your customer. And I think my recommendation here is to engage with your market, your key customers early, and understand what it is that they need in terms of part qualification. And you'll quite often find that although you may not have design authority in your sector, you may have design influence. So it's really good to build those relationships early. I have seen businesses in the last few years that have really tried to get ahead with additive, but they haven't spoken to their customers, and they've made huge investments. And then at the end, the customer has said, well, actually, we don't need that technology at the moment, or we don't have the authority to sort of update the designs. So yeah, make sure you engage early, and that's built into your business case. Financial costs and obligations. So obviously, it is additive can be a significant investment, but what I'm going to talk about in terms of routes into additive adoption is how you can take a step-by-step and slower approach to that. So you're not going to go overnight from being a traditional machine shop, for example, to manufacturing high pressure, high temperature parts, safety critical parts in a jet engine. That's not realistic. So what are the steps, both financially to minimize risk and to learn and to build a more of a time-based business case? So we wouldn't build a business case for additive typically that's based around just an initial investment of a machine, but we plan that out over a number of months and years and what's required. Right, fear of obsolescence is another one. So a lot of businesses sort of are a bit reticent to invest in additive technology because next year there's going to be a new additive machine and it's going to be twice as fast and half the price. And that's not entirely untrue. Things are still advancing quickly, although the technology is becoming more and more mature. So we are certainly manufacturing ready now, but you'll find that there are other ways to invest rather than necessarily traditional buying. So you can think about your make, rebuy decisions. You can put stuff out to supply chain for the additive process itself, perhaps. Manufacturers of additive machines are aware of this barrier as well. So quite often there are leasing schemes or very favourable trade-in schemes where you can effectively give back the old machine and get a new one at the end of your contract. So it's always worth exploring the different options before dismissing a business case because we're fearing obsolescence. I do apologise. So we've got a change of order of the slides. I think this was one of the key. Sorry, these are routes into adopting additive. Yeah, so I talked about actually you're not necessarily going to make your high-profile safety critical parts straight away, but one of the really useful routes into additive is actually to build your own, or start by building your own fixtures or manufacturing aids. Quite often you can do this in polymer as well. So if you adopt polymer additive, it's almost a gateway to train your engineers in the concepts. How do you use the appropriate CAD packages? How do you change your design features for additive? How do you manage additive materials? And a lot of the skills are then common with more of the expensive high investment additive technologies such as metal or ceramics. So it's a really good route way into it. I've also found some people use this entrance into additive exclusively as their business case to invest. So I've seen businesses that make their own injection molding tools or steel tools for aluminium die casting for high volume automotive manufacture, for example. And they found that additive itself has given the advantage of design flexibility. So the example that we can see on the bottom right is cooling channels that are built in close to the surface of a die. So you can actually speed up your die casting process. So you've got better cooling on the tool, you've got a different surface finish, and the tool releases faster. So even in high volume manufacturing, you can reduce your you can cope with reduced takt times. You want to start with using alternative / cheaper materials. So again, if you start with polymers, it's a really good way to demonstrate to your customers that you're developing some capability. You've got the design ethos in there, and it's really useful for the creative rapid prototyping area as well. So actually, if you've got a group of engineers that are iterating a design and you print the parts in polymer, it's a really great way for them to visualize and see how things fit together and reduce the lead times. And of course, polymer machines are typically a much less cost intensive way of implementing. So again, it's a gateway into more expensive technologies further down the line in your strategy. Oops, do apologize. Another point to make in your business case. So I talked about you're not necessarily going to go from nothing to making safety critical, high integrity parts overnight. And it's quite common across the industry and across all of the sectors really to start by making some of the lower critical parts, again, to really get that knowledge, experience, and demonstration of capability into your business before you can then sort of pass that gateway into demonstrating that you've got capability in the really advanced stuff. So for example, in aerospace, you'll find that new Airbus and Boeing aircraft have tens of thousands of additive manufactured parts. The vast majority of them are internal fixtures and fittings. And that's not surprising. It's a safer way to get lightweighting into the aircraft, but increasingly you start to see more and more safety critical parts used using additive as well. So again, low criticality parts as a gateway in, and you may be able to do it by looking at alternative sectors. So if you're in a high integrity sector that's got a lot of qualification and developing safety standards, such as medical or aerospace, for example, it may be that you start your business case off by entering another sector that's more tolerant to risk and change, such as here we've got motorsport as an example. So it's not untypical for aerospace companies at the moment, for example, to switch sectors, at least in the short term, to less risk averse sectors, to be able to learn and try out the new technology. Okay, have we got any questions or comments that we want to highlight on these sections so far?
Oh yeah, sorry, Paul. An interesting question that has come in is the argument around AM and the fact that it saves material in production, i.e. reduces materials waste. However, they'd just like to know what the yield is in producing the metal powder. Has they been advised that it's around 30%, which makes 70% waste in producing the actual raw material itself, which can ultimately affect the total cost of production. Could you please elaborate on that further?
Oh, okay. So I'd say that it's an area that's quite variable depending on the materials that we're talking about. So I guess we're talking about metal powder here.
Yeah, for SLM process in particular.
Yeah, and I think that at the moment is reflected in the cost of the raw material. I'm personally not sure about the yield on the material, but we can sort of follow that conversation up. What I would say is that yes, kilo by kilo, the powder is obviously a lot more expensive than traditional billet and bar that you might be making, might be using to make those parts, and it's a trade-off. So I've seen businesses, for example, in aerospace that are using things like Inconel, and they're machining from solid, and they've actually got sort of 90 to 95% waste of material from the solid. And one of their big costs is actually how to deal with that waste, because it can't just be reused because it's contaminated once it's been machined with coolant and oil and whatnot. So it really depends where this trade-off lies with what product you're making. And I'd also say that I think powder manufacturing is probably the area that's now got the most, or one of the most highly focused areas in AM. There are more businesses coming into it, and the technology is improving. When you're building a business case, generally speaking, like I said, it's quite rare for cost reduction to be the main driver for your business case, which is why we've talked about these other opportunities. But what I would say is you've got to make an estimate that those materials, the cost and the waste of those materials is reducing year on year as the technology improves. So in your business case, if you've got a 10-year plan, or a 10-year or a 5-year cost benefit analysis, then you might want to put a deducting cost of materials on there. So you may say that the cost of materials is going to reduce by 15% each year, for example, as the technology improves. So that's how I'd handle it.
Thank you for that, Paul. And then another question that's come in privately to myself is, what would you say is the biggest barrier to adoption?
So in my experience working at the MTC, so I was involved in a project called Drama, which is about enabling the UK aerospace industry to adopt additive. And I had a lot of companies at the beginning. We worked very closely with the Midland Aerospace Alliance. I had a lot of businesses at the beginning sort of saying, well, we don't really think that's for us. We're a machine shop, we're established. And I think it was almost that realization that actually this is becoming a relevant technology. So a year into the project, some of those businesses that were effectively quite dismissive of additive as a viable process for them have now come back and said, actually, oh, we're a bit scared, we're going to fall behind. Can we get on board, and can we take some of the support packages? So I think it's awareness and skills, and it's almost the lack of understanding of where it can be applied, and that's maybe partly driven in supply chains by lack of direction from some of the OEMs. It's been quite a protected industry, so obviously a lot of companies have spent millions of pounds on researching this, and they've not necessarily put it out there. So I think that demand's coming, and there's a bit of a leap of faith, and taking that leap of faith is almost the biggest barrier.
That's great. Thanks for that, Paul. Just conscious of time and the rest of the webinar. Obviously, we can pick up further questions as we go through, and also any unanswered questions we can then respond to via email as well. So, if you'd like to continue, then please, Paul.
Okay, so I'm going to talk very briefly about costing AM parts and facilities, and the costing modelling process flow. It's a very complex process that we certainly couldn't cover in a 1-hour webinar completely. What factors might be involved in that, including facility installation, what are the challenges with quantifying the benefits, and then really completing the cost benefit analysis and what goes into it, and how do you compare scenarios, and then de-risking the route to adoption as well. So costing parts and facilities really starts with product selection, to be honest. So you really need to strategically look at your whole product portfolio, perhaps understand where you're going to start. Are you going to start with some legacy products, or is it going to be next generation products, or something in a different sector? And then once you've decided on what products you can use, you can start to select the appropriate technology and roadmap towards that technology. So again, it's not a case of you're not necessarily just going to buy a whole new factory, set up a whole new infrastructure, put powder management, additive manufacturing, heat treatment, machining, etc., into place. You're going to really roadmap out over time when would your break points be to make those various investments. And it really is worth understanding the whole value stream for that. So I'd advise, if you don't have, it's a bit of a blatant plug, but if you don't have sort of that expertise already, the support packages offered by somewhere like the MTC, one of the other catapult centres, or even sometimes the machine manufacturers are really very good at helping with that. Identifying the specifications to cost the part. So we've got quite sophisticated models to do this. So if you've got a CAD drawing of your part, effectively we can feed it in, think about the type of additive technology that you're using, the material, the cost of that material, the number of layers, and the laser path that for example in additive layer manufacturing that the machine will be taking. So we can model the build time and the material cost based on a CAD drawing. Again, it's something that has taken quite a lot of development, and then it's a case of actually trying it out in real life sometimes as well, to determine what goes into those. So again, you really need to partner with an organisation, and again, manufacturers are good at this, and organisations such as ourselves that are more agnostic, happy to support with that. Determining your process, which processes are needed in-house. So really along your business case, you may have make v buy decisions. Certainly up front, you're probably looking at more buy decisions. Actually, can we make some designs and can we subcontract them out? Can we learn a little bit about the process? And then at what sort of demand levels would we start thinking about investing in our own kit? What do we want our core competencies to be? Do we actually want to buy a heat treatment plant if actually Joe Bloggs down the road can do that part of our value stream for us? That's probably more valuable. And dealing with uncertainties as well. So I can't really overstate this enough. Some of the benefits that we've talked about, you may have been thinking, yes, but what does that mean in pound notes? So that's a bit old school, pound notes. How do you determine the scale of those uncertainties? So, for example, if you're going into a new market, there's going to be a lot of uncertainty over that in time. So we really want to go around a bit of a feedback loop and minimize those uncertainties. So in that example, you might want to partner up and do some market research, talk to the OEMs, talk to the different sectors, go to conference, do some research on the size of what that market is and what sort of market share do you think you can attain in 5 years' time, and try and shrink that level of uncertainty as you iterate your business case. So this is a deliberately slightly over complex slide, but I think it really does give you the total flow of how to build your business case quite neatly. So again, starting at number 1 with those AM process requirements. So understand what products you're going to select based on your business strategy, and what AM processes are you going to need to be able to do that. Understand the per part production cost. So if you like, number 1 is the fixed costs, number 2 is the variable costs, so material costs, time and labor, facilities, variable costs and overheads. Obviously quite a lot of analysis into this that's difficult to do until you've got the designs of the part, and as you go forward you'll probably determine that you're going to start with a limited number of parts, and in all honesty you're going to make a loss with your new additive investment. That's okay, because hopefully your business case then starts to fill up that capacity with real load as you go forward, and you need to try and model those production costs for what you're going to be making. Understanding the facility cost over the period, the whole life cycle period. So for example, especially with things like additive machines, there are opportunities to there's quite a big second-hand market for them. So really understanding, what's the total cost, but what are you going to get back at the end? And what's that total cost over, let's say 10 years, 5 to 10 years. Then you need to quantify the benefits over the whole life cycle period as well. So again, I think with additive, typically if you're in a corporation that's demanding a 1 or a 2 year payback period for your investment, then you're probably going to, in all reality, have a hard time with your business case for additive. It's likely that the costs are going to outweigh the benefits for quite some time, but when you take it over the 5 to 10 year period and you really build that into a strategy within your business case, and you've broken new markets perhaps, or you've got a more valuable product, then you need to quantify what those benefits are over that whole period, year on year. And number 5 is looking at risk analysis. So what are the things that could go wrong? What's the chances of it happening, and how do you quantify it and have a mitigation plan in place for each of those? You're also going to go around a feedback loop here, where you want to really do more research to understand the biggest uncertainties that you've got in your cost estimates and your benefit estimates. And try and minimize those. So I talked about maybe market research. For cost estimates, you might be looking at getting some help in actually pricing up what all of the different kit would cost you, and modeling the cost per part, to really try and pin those numbers down a little bit tighter. And then number 6, you're going to produce a cost benefit analysis, but not just one. You really need at least 4 or 5 different scenarios in there, one of which always needs to be your do nothing scenario. So what's the cost benefit analysis over my 5 to 10 year business case of business as usual? And that may be that you're risking losing market share if you're in a competitive market where other people are running ahead. It may be fairly stagnant growth, etc., etc. Other scenarios may include things like make rebuy decisions. So you may have a subcontract everything and a buy everything scenario, and then something in between. And what you're trying to do with those scenarios is really understand the different break-even points on the different scenarios, and then the different levels of uncertainty and risk on those. So you can then feed that back to leadership and stakeholders within the business to make a more informed decision about which scenario the business decides to take with its strategy going forward. Okay. So here's just an example, and we use some dummy data here just as a cost benefit analysis. And like I say, you'd want to do it over a minimum of 5 years. For technology like AM, you may be looking at AM as a long-term strategy. And like I say, it's likely that your cost will exceed the benefit for the first few years in a typical business case. But actually, although there is some leap of faith and it is potentially a higher risk strategy, the benefits are also there to be had if you're going to be sort of cutting edge and market leading in this as well. So, and you produce one of these charts effectively for each of the scenarios that you've got as one of the inputs then to get stakeholder buy-in. So how to make your recommendation and what comes next. So typically you'd want to involve, I mean, fairly early on, all of the key stakeholders inside and outside of your business. So actually, does this align with your total business strategy and the direction that you want to take the business in the future? So really senior leadership to be involved in that. Is it value for money? Are there better ways of doing it? And actually, quite often we have people coming to us looking for I sort of call it a shiny solution, because they've seen AM and it's pretty sexy, right? So they want that solution, but actually, if you're better off forging your parts or casting your parts, then we'll tell you, this isn't a value for money solution for you, unless you've got another one of those opportunities to build into your business case. Actually, is it affordable for your business? It might be a really great opportunity, but is it something that your business can afford to finance going forward? And commercially, is it viable as well? Okay, so you really want to make this a cross-team strategy at this point. I'd also suggest looking at external key stakeholders. So talk to the customers, talk to the marketplace, but past and potential future customers. Go to conferences, see what's out there, see what's available. And in making that selection, it's not just about the scenario that's got the earliest payback period. So it's not just about those cost benefit charts, but that is one input. So the break-even point is one input. Cost benefit ratio is one input. We're also looking at the cash flow, social environmental impact, and understanding, is this a conservative business going forward based on strategy, or is it less risk averse? And once you've produced your business case, it's important to know that's not just the end. It doesn't just go in a box and in a cupboard, and you go and do follow it through. It's a living document. Particularly in time, you'd hope that those levels of uncertainty on the benefits and the levels of uncertainty certainly on the costs, things will become clearer. You'll get more knowledge in the business, and you'll actually be able to shrink the boundaries of those uncertainties in those financial business case elements. So it's something that you should really continually do a sort of plan, do, check, act cycle on, and revisit on a regular basis. And you've probably got decision points in there as well, so they certainly need to be reviewed. Implementation planning. So a business case just tells you what, it's an aid to help the business make a decision. It doesn't tell you how to do it. So actually implementation planning and involving everybody in that is really important to remember. And also communication planning, particularly with a new technology or a technology that may be new to your business, such as additive, it's really important to understand who all of the stakeholders are, again, internally and externally, and how to engage them at every stage. And finally, of course, how did it go? Evaluate the process regularly, and get your lessons learned down. It's a good opportunity for the team to learn how to do this and to refine the business case going forward. Finally, it's always useful to create one of these elevator speeches. So imagine you're locked in the elevator with your CEO or your business owner, maybe if you're an SME, and actually within 30 seconds, you know, I'd like to make this investment. It's going to cost us £1 million over 5 years, but the payback could be 10 million and entrance into a new market. And it's going to inspire the next generation of engineers, etc., 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 and really try and state that what's the future state of the business if we do this, and what's the payback, and really engage them in that speech. So that's a really useful thing to do. And again, it's something that we can, you're always free to get in contact, and we can help you to refine those for you. So I've talked a lot about your business case. I'm very quickly going to talk about some of the packages that we've got here. So like I said, I was part of a project called Drama, which has now really fed a whole load of business support packages back into the National Centre for Additive Manufacturing in the UK, all the way from selecting your product, understanding your roadmap to adoption, developing your business case, setting up your factory, health and safety, and seeing how the technology works. So if you're interested in supporting any of those, then please get in touch, and we're always happy to help. And also there's an online knowledge hub that's been launched. So the link for that's just gone, thank you Guy, gone into the chat. He's been standing by the button to do that. So have a look at that, and that's got some really detailed information on lots of aspects of adopting AM. And I'm going to hand over to Colin to quickly talk about training opportunities as well. Over to you, Colin.
Hi, thanks, Paul. Yes, so I hope you've really enjoyed Paul's talk today on AM adoption and helping to build that business case. I just wanted to touch base with you really is how we can support with that activity. So we've got a range of courses specifically aligned to additive manufacturing, right the way from introductory level courses, from what is additive and what benefits can additive bring to your organization, through to developing a business case in much more detail, right the way through to design for additive manufacturing, so you can see the full benefits of those dimensional freedoms that become available through additive design. But what we've also got is a training needs analysis tool, which is free to access through the links provided. I have been informed through the chat that there's a few technical issues with the website, so these links will also be sent out to you directly through the email when we also send you the link to the recording of this webinar too. My contact details are present, and I've also added those to the chat, and my colleagues also just done that as well. So please feel free get directly in touch with me. But I'm just mindful of time, and there's another couple of questions that have come in to the chat while we've been discussing this. So what I would like to do is just pick those questions up, pass those to Paul, and then, like I say, any unanswered questions, please feel free to keep those coming in the chat for the remaining 5 minutes, and we can then still pick those up and send out via email if we don't get a chance to answer them today. So, Paul, one of the questions that has come in, and it's a pretty generic question really, is it seems there's also a barrier of social acceptability of the tangibility of AM. So would you say that we need to look at the sustainability of AM, and do we also need to consider the social awareness in comparison to the technical viability? Can you give some thoughts on that?
I think that's a good question. Thanks for that one, Abdul. I think environmentally, to be honest, there are some concerns. I think there is some research being done and published. It's not my area. A lot of it comes out of the powder production, as we sort of said earlier, because that is quite an energy intensive process at the moment, and it does have some yield issues that are reflected effectively in the price of materials today. I think it is improving, but it's certainly an area for further development. In terms of social acceptance, I think recent weeks has probably seen great leaps and bounds in terms of people, including some of the engineers at the MTC, actually have been making face masks for the NHS at home and other items of PPE. And I think I think that's really created awareness of the opportunities for localized manufacturing, rapid turnaround time. Admittedly, the volumes have been low, but it's taken manufacturers weeks to get online with some of the injection molding tools where they're now making face masks. And for those first few weeks of the COVID outbreak, everybody with a polymer machine in their garage was producing masks for the NHS, which is fabulous. So I think that's actually a really nice example. And the other end of the spectrum, I think in sectors such as aerospace, with the introduction of lots of new standards around ISO through ASTM and the MTC and NADCAP standards, there's a lot more definition about the requirements, the health and safety needs, and the quality and repeatability needs of the processes. So I think that is what's really now making it more of a adopted and acceptable process in those manufacturing areas. And I think that's what's really going to make the difference.
Thanks for that, Paul. Probably got time just for one more question. So how do I determine what process I need and how much will they cost?
Right, there's a whole load of answers to that question. It's difficult when you've not got experience of additive to necessarily look at your products and understand where the biggest advantages are and the biggest limitations are. I would advise getting some expertise and perhaps have a look at your product portfolio, but also opportunities for design for additive manufacture as well, because like I said, the strategic advantages and the cost advantages really come through added value rather than cost savings typically. So have a look at or get some help in looking at opportunities for added value through design for additive manufacturing, and then select the additive manufacturing process based on that. For example, in metal additive manufacturing, typically you get a better surface finish with laser machines, but you'll get a faster process with EDM machines. And you get self-supporting structures with EDM, so you've got less machining. So there are a lot of trade-offs between different processes. And I'd suggest if you're starting at the beginning, it really is worth getting some advice on understanding what the different trade-offs are amongst those key processes.
That's brilliant. Thanks for that, Paul. So I'm just conscious of the time. We've just hit the 3 o'clock mark. So really that comes to the conclusion of today's webinar. I hope you found the subject area really insightful today. We really appreciate the contribution throughout the webinar today as well with your questions. Like I said, we'll be communicating the video links to this throughout the remainder of this week. So hopefully by Friday at the latest, we'll be sending out the links to this webinar. And again, if there's any further questions that you may think of that haven't been answered today or you've not thought of throughout, please feel free to either contact myself or Paul directly, and then we'll look to get those answers for you. And thank you very much. Take care, and I hope you enjoy the rest of your day.
Thank you, everybody.